All right, everybody. Happy Thursday again. All right. Hope you're doing all right. So we're going to wrap up Chapter 2 and finish talking about object-oriented programming, and then we'll look at the first individual project. Those individual projects making up 30% of the overall score. So we'll have 4 of those this semester, and then our final project plus the labs. So in terms of stuff that you code, that's 70% of your grade there, right? The quizzes, I'll post the first one after class today. They're open book, open notes. They're meant to be low stress. So hopefully they're easy points, right? Mostly that's pretty good. So it leaves only the 20% for the midterm, and we've got literally the entire week for the midterm. I don't want it to be you have to sit and do this thing in 2 hours or less kind of assessment, because that's awful. And there are time-bound things you have to do in industry, but it's rarely like, hey, sit down and do this now, and don't get up, don't go do anything, don't go use the bathroom, don't drink or eat, and like, that's silly. So I just want to know if you can do it. That's kind of my goal here. And it's your second programming course, or we assume probably around the second programming course that you've ever had. So again, the goal here is you've got lots of time to work on it. That being said, it's I don't know, maybe a little trickier than something that I would expect you to do in an hour 15 or an hour 45, because we've got a little bit more time. But so it'll be half quiz style questions. You'll have been familiar with the quiz questions. And then half like short answer, or maybe not even short, like long answer. Hey, program this little thing. Not as big as a project, but hey, here's a topic I need you to show me that you can write some code for. That sort of thing. So looking into at least through February, then we'll get first project and the second project and the midterm out of the way. Actually have a spring break, and then we'll get the third project and fourth project done. Then we'll have the last month, all of April, to work on the final project. Again, I'd like it to be done in pairs. If you are really opposed to it, let me know. But hopefully we can do pairs and maybe a trio, depending on our numbers here. I think we had 17 people, but we'll see if everyone makes it through the midterm. So generally, like, I don't know, some people tend to drop off. So we'll see how well that goes. Okay. So let me fire up Pycharm. Should have done this earlier. I always forget to load my IDs. Hey, Trumpet Man, thanks for hanging out online with us. Let's see. So we've talked about classes, we talked about unit testing, we talked a little bit about inheritance. Right, so we're going to do a little bit more focused on inheritance here, because that's the main idea of this first project. So can we take this idea of making classes and then making special versions of them? They do what we want them to do, but then we want to do something additional. And we don't necessarily want to change what's already written, because we might be using that somewhere. So our regular item, who knows where we're using that in our grocery store, right? And I don't want to have to change every single system that uses an item. So if I want to deal with tax, I just change taxable item, right? I inherit from item. I do all the things an item does, right, through this lovely inheritance thing. And then I can change behaviors or add new behaviors. So the changing behavior idea was this overriding a method. That's still loading. Come on, Pycharm. It's like Windows. It looks like it loaded, but it didn't actually load. So if you write a method with the same name and the same parameter list, it can override it. And that, so now when you go ask to buy an item, right, you'll get this buy behavior, not the item class's buy behavior, which is good. That's what we want to have happen, right? Because we want to be able to add the tax to it. Now, I don't want to have to mess with quantities and do all that other stuff. So I'm just still going to ask my superclass, the item class, to do the buy thing. And then I'm going to go add the tax to it, right? Okay, so that's a basic thing of inheritance. I want to look at some other quick examples here. I think we probably did them last semester too, but these are good illustrations as well. So if we make something like a polygon, I should have made that a lowercase, that's fine. So we'll call this class polygon. And it doesn't need to inherit from anything, so that's fine. And we'll have an init method here in Polygon. Now for init, you need to tell me how many sides you have. Right? So we'll have a number of sides. So when you say, hey, I want to make a polygon, you just tell me however many sides. We'll be flexible. So I'll have a self.number of sides equal to the number of sides. And again, we probably could do some sanity checking here, like that you gave me at least one I mean, you can't, I guess you can have one-sided objects, maybe. I don't know how physics work. Probably not. Yeah, so if we're defining it, like if you only had two sides, it's still just a line, kind of like a one-sided. Probably 3, yeah. 3 is probably the minimum, but we'll just pretend. So maybe do some defensive checks. Yeah, we looked at that for the other example, so I don't want to repeat it every time, but it's good habit to have those sorts of things in here. So the number of sides, and then we need a way to track the lengths of our sides. So to do that, and if I don't know how many I'm going to have beforehand, or it's going to be a variable length, I could use a list, right? So I can say, hey, I want a self.side lengths to be a list, right? So I can add in all the lengths of the sides that I need. So right now, I don't know how long they are. You're going to have to go set them later. We maybe could take a list of lengths, or maybe not. It might be a little bit tricky to do that sort of thing. So we'll write a different method here in a second. But we want to start it off with a bunch of zeros. And right now, we don't have a bunch of zeros, right? So what I really want is 0 for the number of sides that I have. So a quick way, right? We could say for side in number of sides, right? We can take self.side lengths, and we can append a 0. Just go add a 0. Right, so we don't actually use this side. We're just using it, I'm sorry, for range. There we go. We're just ranging through. So I want to do however many number of sides. I want to do this loop this many times. So I never use this side variable. I don't care if it's 0, 1, 2, 3, 4, 5, or 6. I'm just going to append a new value. Because with Python lists, we start empty, and we can just keep on adding as we go. Just keep on increasing the size. Now the other way to do that, and honestly, I'm just going to go Google it because I don't. It's one or the other way, and I never remember. So create with x blanks. It's inside. Yeah, this is what we did. We don't want to do it that way. Their answer will probably have. I think it's with multiplication. No? Yeah, this one here. So we can do a none times 10 if we wanted. That's not 0 though, so it's not quite ideal. That could work, but nuns are a little bit ugly. So I think zeros are probably a better default. When we're dealing with lists of other types of objects, none, or that null, like I don't have a value, literally non-existent, might be okay. But because we're going to do arithmetic, 0 is probably a better default here. So just adding a bunch of zeros is probably a little nicer. And I think actually we could do, let's try it real quick. Let's see. I think we can do that. So I'm going to comment these ones out. It's worth trying here. We'll say self.side lengths equals 0 times number of sides. Spell lengths, right? I think that'll do what we want here. So this will be 0 as a single list times this number as a new list. I think that ought to do it for us. So this is a little bit more what you'd expect in Python syntax. You'd do this in other languages, perhaps. So neither's it's not wrong, but you're more likely to see this sort of syntax. And our author loves doing this sort of thing when we get into the data structures. And that's okay. So we're saying, hey, take a list with just a 0 in it this many times and make it into a new list. So a list times a number just gives you that list repeated as a list. It's not really multiplication, but it sort of is. I don't know, it's a funky operator. So then we'll say, hey, if you want to set a side length, you need to tell me which is the side index, right? Which index is it? Is it 0, 1, 2, 3, n, whatever here, right? And then what is the length? So I can go to my self.side lengths at index of the side index and assign it the value of the length. Again, some defensive stuff, defensive checks here, like it's not a negative number would be a good thing to do here. We're skipping past that. I hope that's okay. I don't want to take up too much time. So sure, we'll check all that. So you can set the side length. Now we can get a side length, get side length out, given for the side index, and just return this one here. They just give you the value. So how long is it? Great. And then we probably need a get number of sides. get number of sides returns the self number of sides. Cool. Now the other thing, if we have a polygon and I know how long the sides are, I can tell you my perimeter, right? It's just the sum of, so we're going to define get perimeter. Perimeter. Perimeter? It's probably spelled right. Now, lists, we have a built-in function to get the sum. So I can just return sum of self.sidelengths. Right? We don't have to loop through it adding them ourselves. We got this built-in sum function. We love these built-in functions. So one interesting thing to note here that get perimeter, I mean, perimeter could be an attribute. We could track the perimeter ourselves with a self.attribute, but then every time we set a side length, we'd have to go subtract the old value, add the new value, and do some sort of thing. So we call this really a calculatable variable. So if I can generate the value based on another attribute, right, or if I can derive it based on the values of another attribute, I can either derive it every time I ask for it, or I can keep it up to date in another attribute itself and have to do that work. And a lot of that depends on how often things are going to change and how often you're going to use that derived value. So if I use get perimeter over and over and over and over and over and over again, and I rarely ever change the sides of my polygons, it will probably make more sense to store this as an attribute. If I really only use this once or twice, I mean, I'm changing side lengths a lot, or if I only use it once or twice, it's fine to just calculate it as needed. So when we get into larger scale applications, if you're doing something by the thousands or millions of times, and you have to calculate it every time, that's going to be a little slow, right? Because we're having to repeat that calculation over and over and over. So a lot of that kind of goes into how is it going to be used, and we might not even know. So we just take our best guess and go for it from there. So that's Polygon. Now, if we want to make another class then that extends Polygon, I think I mentioned this last time, if we made a rectangle class. Right? A rectangle is a polygon. Sure, you can add, or it doesn't matter if you add them to GitHub right away or not. So we're going to make a class rectangle, and rectangle is a kind of polygon. Right? The inheritance creates that is a relationship. You are a one of your parent class. Like we're all mammals, right? We're an is a mammal, but we have distinct characteristics. So rectangle then needs an init method. So before, when we did taxable item, we said, hey, my item class had an init method that needed name, price, and quantity. So I needed to ask for name, price, and quantity in addition to stuff that I also needed, like tax rate here. But Polygon needs to know a number of sides. Rectangle always has 4 sides. There's no point in asking for the number of sides in my init method here. We can just say, hey, I want these super init, and we'll tell you I have 4 sides. A rectangle will always have 4. So we always know the number of sides, right? It doesn't need to be passed to my init because I already know what the value is. So depending on if you know the value or not, you can ask for it in your init or not. Oh, sorry, it doesn't know Polygon. We got to add our import. So from Polygon, import Polygon. I like doing one class per file. It makes things cleaner in source control. It's not everyone does that in Python. I mean, everyone seems to have different feelings about what way is better. So if you throw them all in one file, I don't care. If you want them in separate files, go for it. I'm just going to put them in separate files because that's the way my brain thinks, and I'm used to Java, and Java makes you do that sort of thing. So other languages are weird. So anyway, so my init then, rectangle couldn't care. What I could ask for if I wanted is a length and width. Right, because that's relatively straightforward, right? I know that you'll have a length and a width property of a rectangle. And if we wanted to, maybe we default them to 0, right? Maybe we make that helpful. So if you don't know how long it is, great, we'll just give you zeros. If you do know how long they are, you can tell me right when you make the rectangle what length and width are, right? So that's pretty nice. So now the next thing we need to do is Polygon lets you set side lengths of individual sides. If you have a rectangle, your lengths need to be the same and your widths need to be the same. That's a hard and fast rule. So we can't let someone use my parent class's version of set side length. Bad things would happen to my rectangle, right? Part of the class's job is to maintain its integrity and make sure that it doesn't let itself get put in a bad state. So we need to make sure we do override that behavior on purpose, just like with taxable item, right? If you buy an item and I don't charge you tax, I'm going to have to pay the tax as the store, right? And I'm on the hook for it, not the customer. Right? Stores are liable for paying the tax, not the customer. So if they forget to charge tax, they've got to go pay it after the fact. So we're going to define set side length, given a side index and a length here. And we're going to say, okay, hey, if my side index, let's just say if it mod 2. Now, this is a little bit funny here, but I just say if mod 2. With Python integers, right, for an ints, anything other than 0 is true. 0 is false. Anything other than 0 is true. So you'll see this a lot in Python, right? So I'm not going to say, hey, if mod 2 equals 1, I'm just going to say if mod 2, because I'm either a 0 or a 1. Because with modulus 2, the remainder, right, is either 0 or 1. It's never anything other than that. So this is kind of a shortcut. So this is, you wanted 1 or 3, or probably an invalid number, and I don't really care at this point. So, I mean, maybe we could check for side index, you know, if side index is greater than 3, then just nothing, right? Just, I don't know, return false, or I don't know, some sort of thing, sure. Again, we don't care too much at this point. Later on, you know, we could deal with that. So if you gave me a 1 or a 3, right, and then mod 2 is true because you're not 0, then I'm going to say I want my superclass set side length given index of 1 and the length. And I'm going to do it again, then set side length given 3 and the length. Right, so if you give me 1 or 3, I'm going to set both 1 and 3, right, to make sure that I maintain my widths are always the same. You could try and change just one of them, but I'm a rectangle, you can't do that. Right, my class is protecting itself. And if it's not true, so if it's not a 1, it means it's a 0, I'm going to repeat this here, but for 0 and 2. Right? So if you set the widths, go for it. If you set the lengths, go for it. Does that make sense? So we're changing the parent class behavior, and if you gave me 1 or 3, this should be true. If you gave me 2 or 4, or I'm sorry, 0 or 2, I should end up in the else, because 2 mod 2, there's no remainder, 0. 0 mod 0, there's no remainder, so those would be false, because 0 is false. Anything other than 0 is true. Just a weird Python shortcut. So like it's the same thing as saying if side index mod 2 equals 1. Right, same thing here. Right, we're just doing the little shortcut. Python, it's called truthy is the term for it. Everything in Python is either true or false. It's a little bit weird, but anything you can use and just say if, because it's either true or false. Right? It takes a little bit of getting used to. It's kind of a funky thing. So generally the defaults are false and anything else is true. That's all. So like strings, an empty string would be false. Any characters inside of a string and the whole string is true. Just kind of a weird thing. Sorry, my chair here is being funny. Okay, so we can set side length. Now the other thing we can do, other specialized behavior, we've added additional behavior here. I can get an area out, right? I know what my area is for a rectangle. I'm going to return my super.getSideLength of 0 times my super get side length of 1. Length times width. That's your area. Right? But I don't have that method myself. Right? So I'm going to ask my superclass for it. I could also say self here, because I do have a method of that name. It's not defined here, but because I inherit from Polygon, rectangle has a method named getArea. Right, so if I looked at rectangle, if we went and added an import here for rectangle, so from rectangle, import rectangle, and from polygon, import polygon. Right, so somewhere in my main method here, we wanted to make a rectangle. So rectangle, I don't know, small rectangle equals rectangle, and then we could give it, I don't know, how about 2 and 4 for length and width, right? Small rectangle, if I put in dot here, notice I get all my public methods. So I have a get perimeter already, I have a get side length, I have set side length, I have get area, I have get number of sides, and the Pycharm type ahead here is even telling me what class those come from. So get side length comes from polygon, set side length comes from rectangle. Hey Hector, thanks so much for donating those bits to the Student Scholarship Fund here at the U of M, University of Michigan, Dearborn, College of Engineering and Computer Science. One of these days I'll be able to say that fast without tripping over my words. Today's not the day. Get area comes from rectangle. Init comes from rectangle. Right? These are the polygon versions here. There's a bunch of other stuff you see, and they say object. Behind the scenes, everything in Python is actually inheriting from object. So there's a base class called object that has a bunch of cool things that it does. All these things here, everything is an object. It's implicit. So with polygon, I don't need to say I inherit from object. I don't put parentheses object. Right? We don't need to do that because it just happens automatically, right? Which is pretty cool. So all the methods, you can see which class implements them here in our little type ahead suggestions. It's pretty cool. Okay, so self dot is fine because I do have a method get side length. The reason I might want to use super is if I had my own version of it, self dot would do my version. So if I'm not careful, if I did self dot here, like I have a method called set side length, but calling self side length calls this version, which would call this version again and again and again and again. I'd be in an infinite loop. By calling my superclass version, I get the superclass version in Polygon runs and it's done. It doesn't call this one again. So this is important that we're explicitly calling the superclass version here. In this one, it doesn't matter which one we use because they're the same version. Right, so like we can say it doesn't matter self or super version, they are the same, right? Because the self version still is the superclass version. I haven't overridden it, I haven't changed anything. So there's no distinction. Does that part make sense? They're really the same thing. Okay. Now we could go one further if we wanted to, right? And you can inherit from things that inherit from things that inherit from things that inherit from things. Go nuts. So let's make square. Why not? Right? And you guessed it, squares are rectangles. You guys are so smart, right? So class square inherits from rectangle. It doesn't need to inherit from polygon. It needs to inherit from rectangle because, I mean, technically a square is a rectangle. I'm sorry, square is a polygon, but rectangle knows how to do the get area correctly. So that's kind of cool, right? We can be a little bit easier there. So we'll say from rectangle, import rectangle. Okay. Then we need our init method. Now, my rectangle superclass wanted a length and width optionally. Squares just have length. So we could ask for length optionally if we wanted. And then I can call my superclass init method and give it that length both times. Right? The length is also the width here. So again, whatever parameters make sense for me, if I know what I'm giving to my parent class, go for it. These were optional, so I don't even need them, but I can just give them zeros as my default. Yeah, so the superclass is the first superclass. It's the direct parent. So like Polygon, we might call it like the grandparent. I don't think you call it ever super. I've never heard someone say the super class. But yeah, so it's the first parent is your superclass here when we tell super init. So we'll give it length and length, right? Other than that, square doesn't do anything else different except that you can't change length and width separately. So I need to again override the set side length here. This time I'm going to call super set side length given the length. So index 0 and the length, and index 1 and the length. So I'm going to set length of the parent rectangle class, the super rectangle class, which will set 0 and 2, and then I'll set width to the same length, which will set 1 and 3. So one call to set side length of a square turns into 4 calls to the polygon set side length, right? One for index 0, one for index 1, one for index 2, one for index 3. Whoever's using square could care less how that happens. All they know is there's a public method to set a side length. They might think it's a little bit silly that you have to tell it a side index. Right? So if you wanted to, you could add another helper method like set length, right, for just a generic length here. And we could call self.set side length given 0 in the length, right? Doesn't matter what we give it here. So this is just a nicer looking helper method, right? So I'm just going to say, here's a length method. You don't have to tell it side length. If you say what side index on a square, they might be a little confused because they don't really know that we're actually a polygon in disguise. Right, so like this one's just easier to use in your other classes, wherever you're actually using this one here. It's a little bit friendlier. Does the exact same thing as set side length, but then you don't have to give it an index, because why would you set one separate anyway? Like, it doesn't make a lot of sense. Where rectangle, maybe it makes a little bit of sense, 0 or 1 indexes here. Again, indexes are still a little bit funny. It might be nice to have like a set length and a set width in rectangle. We could do that if we wanted to, right? So we could have set length and set width. Set length given length and set width. Width, set width given a width. So to do that one then, right, we would say, are lengths the 1 and 3 or the 0 and 2? I don't actually know. Probably doesn't matter, but sure. We'll just say self.set side length of 0 in the length, and this one could be 1 in the length. And the width, right? Because we said width. Width. Sure. So length will be 0 and 2, width will be 1 and 3. Why not? So just helpful to make easier. That's all these are for. Just whoever's using our class then has a prettier looking method rather than you have to tell me what index. Right. Yeah. No, I don't think so. I don't actually know mathematically. I'm not much into math. I'm sorry. I felt like length was always. Is it always the longer one and the width is shorter? I don't know. That's a good question. Maybe not mathematically correct. Might not be mathematically correct. Sure. For our purposes, we're okay. This is programming land. We're not math land. We don't have to be that accurate. Yeah. So for super, we're going to use not my version, but always the superclass's version. So when we're setting side length in rectangle, if I were to call self.set side length, it would call my version again. And so if I did self.set side length, it would just repeat the method over and over and over and over because it's calling itself. The method would call itself, and would call itself, would call itself. We'd be stuck forever. Where super goes out to the superclass polygon version, runs it, and it's done. So for the get area, we don't have a get side length method that does anything special. So it doesn't matter if we're saying self dot or super dot. It's the same method because it's really defined in Polygon anyway. So both of these will run the Polygon get side length version. We don't have our own, but we can still call it from self because we are a kind of polygon through inheritance. So we have access to it, but the actual method that runs is the exact same one. With this one, calling super runs the Polygon version, calling self would run my version here. And we don't want my version to run over and over and over and over again. Bad stuff would happen. But for these ones, like set length and set width, we want my version to run because I want this special one that says, hey, if you give me 0, do 0 and 2. If you give it 1, please do 1 and 3. So self calls the one defined in your class, or if you don't have it, wherever you have it from your parent class, wherever you've inherited it from. So it's always going to look in the class first, And then it will start looking at the superclass and the superclass and the super grandparents and things like that, all the way up the chain. Yeah. So self will always look at the current class first, and then work its way up that chain to see where that method's defined.
Can you kind of decide the priority of each class, or
it'll always go next, like one generation at a time, until it finds one that matches. Yep. If you wanted a really super specific one, like you could say you wanted polygon dot, this is really weird, but you could then call set side length this way. Doing it here though, it needs self, so you'd have to pass it yourself. It's really funky. So you could pass it self, and then you could pass it the side index and the length. And weird stuff happens. You generally don't want to do stuff like that. There's ways to do it if you really want to mess with it in Python. Python lets you do a lot of weird things. We're going to try and avoid the weird things. Yeah, so this one would be the very next one that it finds. So it's always going to check rectangle first. If it doesn't find it in a rectangle, it'll keep looking up the chain, up the chain, up the chain, up the chain. Yeah.
So when you import rectangle, does it automatically import?
When I did where?
When you import rectangle, does it automatically import polygon?
Yeah, so basically this import line is taking all of this code here and jamming it in that location. So it's going to get the from polygon, import polygon as part of importing rectangle. So like in my main here, I probably don't actually need to import polygon, right? I can just import rectangle. Or if I wanted to just import square, right, from square, that one should work. And I think I can still make, so I haven't imported rectangle by name. So these imports are a little funny. So you can just say, hey, I want to import square. And all that lets you do now is say, I have this square file, which is a module, and then I can say square dot. So square is now the module dot, I can't spell square, square dot. Now it says, oh, hey, did you want the square class or the rectangle class here? So square dot square then is the square class. This being the module, this being the class. So a lot of times we'll say specifically import a class from a module. That way you don't have to retype that same thing. So like in this case, we don't have to say, where do we go with our items? It doesn't have to be item.item. So it just kind of depends on how you write your modules. So I only have one class per module, per Python file. A Python file is a module. I think it makes it easier for me to do these from imports like that. So from square, import square. And then I can make my squares. So I don't need to say square dot square, I can just say square. You know, square is a square. Did I spell it wrong? SQ square. Right, and give it a length of, I don't know, 4 or something. Or maybe this is a small square. So if I don't import explicitly though, like from rectangle, import rectangle, did I spell it wrong again? Square? I did, I misspelled square. Oh my goodness, that's why. Okay, I'm going crazy here. No wonder that looks so weird. Okay. Square, square, square. Okay. I think it's happy now. Yeah, okay. So now small square is okay. But now, if I haven't explicitly imported rectangle or polygon, I can't just say, hey, I want a rectangle. Is it gonna let me? I don't think it will. Small rectangle equals a rectangle 10 and 2. Yeah, it says unresolved reference rectangle. It doesn't know what a rectangle is because I haven't gone through this import method for it. So it's a little bit funky. So you could say, from rectangle, import rectangle. And then I can just use the word rectangle here. Now it's happy. All right, so that's the gist of inheritance here. We'll do more practice in lab on Tuesday, doing our own practice inheritance here. So actually, I kind of like the book's example that they go through, but we're going to play with it a little bit and try and do some calculus with it for fun, because sequences and series are just the coolest things in my mind. So we're going to kind of prove a couple theorems in Python, which is fun, and show that it works. So if it sounds really dull, it's kind of interesting if you appreciate math. It's not hard math at all. Though Python does all the work for us. We just look at the sum of a geometric sequence with an R value of less than 1. Okay, that probably doesn't mean a whole lot, but I was excited when I learned it because I actually went back later in life and took calculus as some prereq classes for the doctoral program here, because I never had to take it earlier, which was kind of nice. But I think I appreciated it more in my 30s than if I would have taken calculus at like 18. But it was really hard to memorize the formulas. I had to take Calc 2 twice because I just couldn't keep enough of it in my head, and we didn't get cheat sheets with formulas on it. That was really sad. And that's what I'm going to blame, not the fact that I didn't do the homework, because it was optional. You didn't have to do the homework, so. Okay, all right, so it's got that. So let's talk about the project. Let me grab assignments here. And let's make a new assignment here in projects. This one is an old favorite of mine called Trek Wars. So we got 2 weeks for this one. So it'll be due February 3rd, the start of class. So the plan is February 3rd at 3:30, I'll go over my solution to it. So we got 2 weeks from today to get it in. And that's why I don't take things late, because I'll have gone over the answer and then I can't give people credit for it. I'll post a rubric here in a minute for it. And let me grab, I've got to actually have a document for it here, which is kind of fun. If I can get this thing to load. Hey, look at that. You can have my folder in my quick access. Trek Wars. Maybe. Here we go. Oh, do I probably have the PDF. Sorry. Okay. Yeah, I don't think I have any due dates in here, right? Feedback. Okay, so we're also going to talk about UML diagrams. We'll spend a little bit of time talking about those in just a minute, because we want to cover that one as well. So for Trek Wars, we're going to cover classes, inheritance, and this UML thing. We didn't do a great job of that last semester, I apologize, looking at some of those diagrams. So we'll spend a little bit more time. In lab, we should have access to Visio. I don't actually have it installed here locally. Visio is probably the better tool to use for it. There's a lot of online free tools, and really I'm lazy and I use Word, because you can do them in Word. They're just not official or pretty or anything. So we'll look at Word for that in a second. I think it'll load. I think I confused my computer. All I wanted was Microsoft Word, Windows. Come on. Come on, there it goes. I already have Word open. That's probably why I was confused. All right, so a blank document. We'll show you how to make those in just a minute. So we're pretending here that our job is to make just the classes for this game here, for this online space battle game. Never been heard of before, never thought of before, brand new Trek Wars. No one's ever thought of this kind of thing. That was the joke. So we're just writing the classes and tests for them, the unit tests that we talked about on Tuesday. So we're not writing the game logic portion. We're not writing the graphics part of it. We have other people on our development team at our studio who get to do this work for us. We're just writing the classes. So we're going to write a couple classes. We've got an enum. I got to talk about that as well, adding to my to-do list here, for different alignments. Enums are great ways to put types into code that you actually get to use code for instead of a string value. So passing around a bunch of strings is really failable and kind of slow and takes up more space in memory, because strings take up a lot of space, right? If you have 2 bytes for every character. So enums are a nice way of putting names to like a nicely enumerated list. So short for enumeration or enumerated or that sort of thing. So we're going to make a base class for ship. So ship's going to have a bunch of attributes. It's going to have a name. It's going to have an alignment. It's going to have an X location and a Y location. That should be spelled out better. Y location. That should probably be spelled out too. Alignment here. So the type of name we're expecting to get a string out. Now Python, again, will just take anything that it gets, but this is what we expect to have. And this is what we're going to use in our UML. I'll show you in a little bit. So the type we expect here is the alignment. X location is an int. Y location is an int. You get a range here of how far your ships are able to shoot other ships. You have a current health integer, you have an attack power integer, and you have a max health integer. So you get lots of different attributes here for our ship class. And then methods, or our functions here. We have an init method that should accept values for all these sorts of things. It should accept a name as a string, an X value as an integer, a Y value as an integer, an alignment as an integer, a max health as an integer, a range as an integer, and an attack power as an integer. Notice it doesn't accept a current health, right? We're going to assume your current health starts at max health. So you don't need to pass it a different current health, because we're going to assume when you build a ship, it probably is at full health, right? You don't want to make damaged ships because your shipyard would just suck. We have a method here that will attack a target, which is a type of another ship. It doesn't need to return anything. There's no returning that happens here for attack. We'll have a get type here, which returns a string value of the type of ship that it is. We have battleships, we have cruisers, we have corvettes, and we have repair ships. You have a get X, a get Y, right, returns your X and Y coordinates. You have a get alignment, returns your alignment here. We have a status that returns a string. Down below, it tells you what that string looks like. We have a move method that changes your position, your X and Y position, based on the type of ship, and increases your health by 1 up to max. Right? Your health should never go above max, but if you're below max, it should go up by 1. You have a change alignment that changes the alignment of your ship, and you have an assess damage, taken some amount of damage. So that should be amount, right? Amount. So changes the health by the amount, making sure it doesn't go below 0, right? You can't go any lower than 0, dead, and you can't go any higher than max, right? So some of those bounds checking that we're going to have to do to make sure we don't get into a bad state here. So those are methods or functions of the ship class. And then we're going to derive from ship for a battleship class. So this is battleship. Wow, that got weird. I get a battleship. Why? This, yeah, that shouldn't be there. The formatting of this was awful, sorry. So a battleship always has a range of 10. It always has a max health of 100, and it has an attack power of 10. In addition to that, it has a new attribute called torpedoes. So battleships have torpedoes, which you'd think submarines, but we're in space. Just, you know, all ships are technically submarines in space, right? I think they're all airtight. They don't have open decks. Sure. It doesn't have to make a lot of sense. It's okay. And then when we move, battleships, just because we want to make this kind of a little bit easier here, will always move -1, -1. So whatever your current X is will go down by 1. Whatever your current Y is will go down by 1. So battleships just go in a direction. Once they turn on their thrusters, they're stuck, and hopefully they don't run into a planet or a star or something awful like that, right? Again, doesn't have to make a lot of sense. We're trying to simplify some of these stupid game mechanics. And then it will attack a given target of a ship. When it attacks, if it has torpedoes, it does an additional 10 damage and takes away a torpedo. If it doesn't have torpedoes, nothing special happens. The regular attack, right? So does damage to the target ship if it is within range, and does the attack power damage. That's right, attack power damage to the target ship. So if it's within range. Right? So if something's within range, we have your distance from XY to other distance to XY. You do Pythagorean's theorem to find the hypotenuse, right? Check if the range is less than that. I hope I don't have to explain too much of that. If the math trips you up, don't worry about it. I'm happy to help you with the math, but I trust you folks, or at least in Calc 2, and can figure out distance between 2 points. I've had people get confused on it before, and that's okay, because like we're in coding land and we're not thinking about math, and you're like, well, how am I supposed to calculate it? And you're like, just pretend it's math. Yeah.
So when you attack, you reduce the power damage by 1.
Well, you'll reduce their current health of the target ship by your ship's attack power. So for battleships, their attack power, that should be attack power, is 10. So they'll do 10 regular damage in addition to 10 extra damage per torpedo, if they have torpedoes. For cruisers, they're derived from ship. Their range is 50, so battleships don't get to shoot very far. Cruisers can shoot from really far, but they only do 5 points of damage each time, and they don't have as much health. They move a different direction and faster. They move positive 1x, positive 2y every time. Again, steering is hard in space, apparently. They can attack, the same thing. A corvette derives from ship. Its range is 25, and its max health is 20. So these ones are a little bit fragile here. When they move 5 by 5. These things just fly. But when they attack, they do a different thing, because everyone loves corvettes. So their attack will actually change the alignment of the ships. So this idea, we have this alignment. We have an us team, we have a them team, and then we have the chaotic team who hates everybody. So us ships don't shoot other us ships. Them ships don't shoot other them ships. But if you're a corvette and you're team us, you'll convert a them ship to the us team. If your corvette is team them, it converts team us to team them. Because everyone loves corvettes, so they just want to make you join their side. So their attack doesn't do damage, it just changes the alignment of a ship. Right, that's the change alignment alignment method. So this idea that ships had a change alignment function method, we could change their alignment. So us changes to them changes to us. Chaotic ships just hate everybody, they'll never change. We can't change their mind. So this is us changes to them changes to us, chaotic. I can't even spell chaotic, never changes. So if you're team chaotic or your alignment is chaotic, you're not going to be able to be changed. You're still just going to shoot anybody and everybody you see. But corvettes will use that change alignment method on their target ship. Yeah. No. So a chaotic ship will shoot other chaotic ships, but it won't ever target its own self. Yeah, so like if there's 2 chaotic ships near each other, they'll fire at each other. And then a repair ship derives from cruiser, not from ship. Right? So repair derives from cruiser, which derives from ship. Its range is 25, its max health is 20, and if it were to attack something, it will repair a ship of its own kind to max health. So if its alignment is the same, so a us repair ship will repair another us ship. It won't repair a them ship or a chaotic ship. You can just assume there won't be chaotic repair ships because they always hate people. They're never going to go repair anyone. So like there won't be one that's chaotic because it doesn't matter there. The same with corvettes. You won't have a chaotic corvette because it can't convert to your team, right? So there would be no team to convert to. They would just, if you tried to convert them to your team, they'd hate you too and start shooting at you. So that's not all that great here, okay? So there's no input for this at all. All we're doing is building the classes, right? And we're writing unit tests to make sure that they work. So for that status method, you should return the name of the ship, the type of the ship, the current health of the ship, and the location of the ship, and if it's a battleship, include the number of torpedoes. So we're going to use this status string here. Imagine like you hover over a unit or something in a game, it gives you like its little status display, sure, or maybe if it's a mobile game, I don't know, we could spit some text out, or who knows where we're going to use this. If we got to pitch it to the investors and see if they like the idea of Shrek Wars, so this real original kind of space game. So except for repair ships, attack only works if the target of the attack is the opposite alignment and within range. So us attacks them attacks us, chaotic ships attack everybody, repair ships only, quote, attack or repair the ships of their same alignment. Okay? So we're going to turn in the diagram of our classes to Canvas and the feedback pull request. And we're going to include unit tests for 100% code coverage. This is going to be a little bit tricky. It's not too bad, but we're eyeballing it. So every time you have an if or an else or a something block, you have to make sure one of the tests make sure that code runs, right? So for our regular attacks, if we're checking to make sure you only attack in opposite alignment, we need to test that, yes, attacking in opposite alignment works, and trying to attack someone of the same alignment, we don't fire, right? You're like, Captain, fire the torpedoes, and then you say, no, it's our own team, we don't do that. Right? We need to make sure that that code actually runs if we have something happening there. So all the blocks need to get running at some point in the tests. And then the UML class diagrams, we talk about those real quick. So in Canvas here, I think I just got to go upload the file here, sorry. So it'll be a online file upload and website URL. I think that lets you do both. I'll double check that in a second here. And then we go add that file. And where'd it go? Let me save it. Okay, so here in Files, drag and drop this in. I think that dragged and dropped. Oh yeah, Cortana wants to help. Unable to transmit. I have to relog into Canvas? That's bad news, bears. Just refresh the page. Huh. Okay, I'll post it in Discord first. So let's do that. So let me go my Discord here. I'll get it back into Canvas later, but I want you folks to have it here. Is it me that's failing? It's the files open. Oh my goodness, it is me. It is me. The file's open and Windows is trying to be helpful here. That's what's happening. Now retry. Okay. Yeah. It could have just taken the saved version, but sure. Sure, why not? All right, let me go edit that. We'll add the link to it. And we'll call project 0 because, you know, indexes start with 0 and we're cute like that because that's what happens in programming land. And let's add a link to our file. Files.
UML diagram steps like where it starts to where it ends.
So that's there's activity diagrams and there's UML class diagrams. So we're going to focus on the UML class diagrams for this. We'll talk about that. An activity diagram is the sequence of what happens where and what class does what thing. That's what we skipped last time. So I meant to talk about that and I forgot. So we'll get to it. For a UML class diagram, actually these are relatively easy to do in Word. I like to insert tables. So you do a 3x1 or 1x3 table. And this is, we'll do the exact same thing here in Visio as well. So we can play with that in the lab. In the top box, you get the name of the class. So we'd have like Polygon. In the middle box, you get all of the attributes. And now in UML, there's notation that you use. You use a minus sign if something is private. Use a plus sign if something is public. And there's also protected, which is a pound sign. We don't do that in Python, so don't worry about it. So we're going to use minus and plus. So minus means it's a private attribute. Plus means it's a public attribute. It's just a UML notation because other languages don't have that same convention that an underscore means it's private. And UML works in any language. So I can write a UML class diagram and I can write it in C++, I could write it in C#, I could write it in Java, I could write it in Python, I could write it in Perl, I think. I don't actually write Perl, but right, pick a language, you should be able to write a class in it as long as it's an object-oriented language given a diagram. So that's why we use this sort of notation. So we'll say, hey, I've got an attribute named, this is what, number of sides, and then you put a colon and you say the expected type. So we're expecting integers. Again, Python is a little bit funny and doesn't enforce this. We say that it is not strongly typed. So other languages are strongly typed in that if you say something is an integer value, it will just croak and die if you try and give it something that's not an integer. Python says, oh, you told me the number of sides is the word apple? Okay, you now have apple number of sides. And later on your program will crash. But again, Python's a little bit funny sometimes. No, not a dash. I don't want a dash there. Okay, so number of sides as an integer. Again, we generally don't have public attributes. There are cases where public attributes are great and useful. we're not getting into them right now. So most of ours are going to be private. And then I'll have a side lengths, right, which is a list, right, of integers. I don't know, we'll just say list. I don't know, Python, or just put the parentheses, I guess. Any way you want to put it is fine. I think list is probably more proper. Right, calling it out, hey, this is a list. And we could be fancy and say it's a list of integers if you wanted to, but again, doesn't matter too much. So we're saying these are my private attributes. So we have name of the class in the top box, we have list of attributes in the middle box, and then the bottom box gets all the methods or all the functions. Now here, public and private matters because we can write methods that are also private. So I don't think we have any in any of these. We never did any, but like a helper method, like something where you don't want to have the same code twice, but it's not something that you should expose publicly. Like someone doesn't need to use this outside of my class here. So something that you might run into that would be a good private method. If we go back and think about Trek Wars here for a second. See if this one loads. When you have to say, hey, is your ship within range of my ship, right? And we've got our nice little grid here, and we've got, here's a point here, and here's a point here. If every time you have to check to see if something is within range, and you do this math to find out what the distance of that one is, right, to find that out, that is a very good candidate for something as a private method, like calculate distance between 2 points, or calculate distance between my ship and another ship. Right? So we could say, hey, that would be a private method like calculate distance, calc distance. Or you may even have a method like is within range, right? Because that has a meaning, right? You know your ship's range, you know where your ship is, you know where their ship is. Lots of different ways of going about it here, right? So when I do my solution, you'll see how I approached it. There's no wrong way to do it. Some ways might be arguably better, but again, as long as it gets the job done, I don't care. So I'm not too particular about how you go about solving it. Okay, so those sorts of things might make sense as private methods or functions because you don't want to have the same code twice. If you have the same code twice, you should feel bad about yourself. And to make yourself feel better is you make a function, right? That's how we make ourselves feel good. We write functions. So for Polygon then, we had a public function of get side length, and then we needed an argument of the side index, and we assume we want that to be an integer value, and then we're going to return a value of an integer. So the arguments still go this backwards format of the name colon the type, and then the methods, then if they return something or not, colon return type. So we have a method like set side length here, given a side index as an int, that's an underscore here, right? A side index as an int, and then we had another argument of the length as an int, and then we're going to say null. We didn't, or none. None's the proper Python term here. We don't return anything. Other languages might call it void or null, right? None, null, void. I don't really care one way or the other. Again, this is somewhat Python-centric, but the idea of a UML class diagram is it's really a picture-ish, but it's got descriptions here, and you can make a diagram and show someone, and they can look at it relatively quick and say, okay, I think I know what this class does. I know what attributes it has, and I know what the methods are. I don't know how to write it all yet, but I can take that as my to-do. So we got get side length, we have set side length, and we have a get perimeter. Perimeter returns an integer value. Right? So we get name of the class, we get list of attributes, and then we get list of methods where we have arguments or parameters are defined and return types. That's the UML class diagram. Okay. The other cool thing we do with UML class diagrams is that if you inherit from another class, right, if you are another type here, so if we were to center this one and say, hey, this one's rectangle, we just get to draw an arrow. So you can actually insert arrows, I think. Yeah, where is it here? It's the drawing tool. Hang on, where is it? You can insert arrows. I know you can. It's been a little while in Word. Shapes, there we go, shapes. So you can insert an arrow here if you wanted and say, hey, I am a one of these. And the arrow in UML class diagrams indicates inheritance. You say, by the way, I'm one of these. And that's how you show inheritance. Okay, and then we would still then have our list of attributes. So rectangle didn't have any new attributes, right? So it'd just be blank. But it had a new method then for get area, return an integer. And then we also want to indicate that we had the set side length method. Set side length, given an side length, side index as an int, comma, the length as an int. Length as an int. And that one didn't return any values, it was a non-return type. But because we define it, we're going to include it in our UML class diagram. So just by seeing that they match, we'll know, oh, hey, it's going to override. There's a couple other cool things we can do. Visio does some cool stuff like automatically because it knows, oh, hey, it overrides, but this is perfectly fine. And everyone's got this tool. There's also an online, it's like draw.io or something, I forget. Online, UML class diagram, drawing, I forget what the tool is called. Visual Paradigm? Oh, they have a free tool. Okay, this used to be a really expensive tool, but their online tool, I guess, is free. That's cool. I thought there were some other good tools for this, but sure. There's a couple different ones if you want. I think Word's fine. Right? So like you can just Google UML class diagrams and you'll see you get all sorts of cool pictures of them. You can have additional information about classes as well. So like an account can have transactions, so it can show a relationship, right? This sort of thing. A bank can have ATMs. An account can be a type of savings or checking. So you can add some additional information. We're not going to go super deep on it here. This might be a little prettier one. That's not even all that pretty. But one of these. Yeah, so a book is in a library management system. Accounts, users have accounts. I don't know. You look them all up, and generally they follow the same sort of format, so you can get an idea of what the class is and what it has. Oh yeah, here's Visual Paradigm. There we go. Not for commercial use. Sure. So here's a tweet. A tweet has coordinates, I guess. Sure. A user has tweets. So that sort of thing. You can do fun stuff with it. Lucid chart. That's what I was thinking of. That's a pretty common online tool. Lucid chart. I think that's what it is. I think this was a free tool. Yeah, this was a pretty good one. A lot of people like to use this one. They did not get good reviews on Facebook. Go figure. All right, so that's our UML class diagrams. We can practice these more in lab as well. When we talk about our classes, we'll do diagrams for our classes we write in lab for good practice. So for the project, we're running the classes and the tests. There's no code that actually runs the game here. So we don't have a way to create ships and place them on a battlefield somewhere and run them around and let them blow up and do that sort of thing here. We're just writing the classes and testing that they do what they're supposed to do. Okay? Does that part make sense? Okay? Yeah, cool. And if you got questions, let me know. We'll practice all this stuff in lab on Tuesday and before we move on to new stuff. So next week, we're going to move on to recursion, which is the next topic. While you still are working this sort of thing, we'll do all sorts of recursion stuff. And then the week after that, we're going to pick up the array-based sequences, I think. I'll double check here. You can find the syllabus. And then that next 2 weeks from today, then we'll go over the solution to this one. And then we'll talk about the project one, or the second project, right? Because we're doing our indexes start at 0 kind of thing. This loads, come on. So we'll have next Tuesday's lab and the week after Tuesday's lab are great times to bring questions. Generally, you can get the lab done and have a little bit of extra time. I'm happy to meet with you other times as well. We got all sorts of cool collaboration tools. And I do now have access to an office location in the CIS building. So they did figure that out. So I don't have to drive over to the Fairlane Center. That was a great place to have offices, apparently. All right, it's not even loading. It's not my day today. But so we'll have 2 different lab times if you want to bring some questions then, or if you got anything you're working at it from home, just shoot me messages. Happy to hop on and I'll get you pointed in the right direction for these sort of things. And we can go from there. Okay? Oh, and Trumpet Man, you wanted the knock-knock joke. That's the bonus. If you follow along on Twitch, you get a use your channel points for silly things like knock-knock jokes. Just honestly, sitting here listening to me for an hour plus straight is really difficult. Like, I get bored of hearing my own voice that long. Okay. Oh, this is a good one. Knock, knock. Who's there? To. To who? No, actually, it's to whom. Man, knock, knock, and grammar nerd. I love it. Okay. Put that one at the bottom of the stack. We won't see that one again for 100 more redemptions. All right, yeah, it's not loading here, but that's the plan. So we got time in lab. If you want to ask questions, great. Other times, happy to meet with you. Tuesdays, I'm here between lab and class, so that should be fine. Thursdays, I can get here a little bit early if you want to meet then as well. After class, generally, I've got to run right away. So I try to beat the traffic best I can to make it back home. If I wait too long, it takes like 50% longer, which is awful. All right. So there's no user input. Yeah, so there's no, like the Connect 4 project, there's nothing where you have to run a main method and ask the user to enter anything ever. Because ideally it's going to be some sort of like pretty graphical game, because otherwise who's going to want to play this awful thing? Like, you can't even steer your ships. Maybe that's a feature we could add in later, right? So that's fine. Yeah, so we've got ship is the base class, and then we have battleship derives from ship, we have cruiser derives from ship, and we have repair ship derives from ship, and then let me load it up again because I'm going to say the wrong one. One of them derives from cruiser. Oh no, so repair ship derives from cruiser, the corvette derives from ship. Right, so the ship is the base class, battleship derives from ship, cruiser derives from ship, corvette derives from ship, but repair ship derives from cruiser. So that's where, so polygon was the base class, rectangle derived from that, square derived from rectangle, that sort of thing. So we just follow down the chain here. And again, the goal is to not have the same code twice. If you do, it's okay if you feel bad about yourself. It's still your second semester programming. Like, it's not the end of the world. You don't have to actually go and change it. You're welcome to have the same code as many times as you want, right? That's however much you really want to type or copy paste. It's all up to you. The danger with copy pasting and having the same code in there more than once is if it's wrong, you now have to go change it multiple times. So just keep that in mind. So it's also advantageous to only have code in places one time. It's easier to fix when things go wrong. Yeah, I mean, you're welcome to make it play if you want, GG Hockey, but that's above and beyond what we need to tackle for this objective here of just using classes. So yeah, it's not a very interesting game either, because the ships just kind of float around and can attack each other. So if you could steer them, it might be more interesting, or if you had like planetary bases, and that's, so my Epic just gave away a galactic civilization game, and my son was all excited. So we played Civ 6 together, which is interesting enough for a while, and then it got kind of boring. But he's like, oh no, this is space now, but it's basically the same game as Civilization, but you have spaceships, and he's all into it now, so sure. Yeah, Civ was fun for a while, but it got boring because I think it was like the same thing over and over and over again. So, all right, well, that's all I got. You folks take care. I'll post this out to YouTube here in just a minute, and you folks know how to get a hold of me.